Hello students, today I want to demonstrate you that subjective problem solving whose final answer you don't know, just question is been given, you read and solve it. That problem was old method, but it was difficult to correct it because each steps you write it and multiple people are to be there to correct number of answer scripts. Say in each examination some 100 problems are being given, 100 problems to correct we require a lot of people. A machine cannot do it, whereas an MCQ will have bubbles like this. Out of that you will darken the circle and a human being need not required to correct this paper. That OMR, optical marks recorder, will be there. It can scan and within seconds hundreds of papers it can scan. To make the correction easy and to avoid correction errors, this kind of system is been developed where you will be given options A, B, C, D. Okay, in the examination you have to do it, but I will prove in this example that one subjective problem is equal to 100 MCQs or more than that. So how question is been given, I will put it on the board now. So there is a question here. I'll take some resistances, 3 ohms, 4 ohms, 5 ohms, 6 ohms, this is a symbol of ohms, resistances, and this is say 12 ohms, and this battery is say 18 volts. So now when we start solving this problem, they can ask what is the equivalent resistance, or they can ask what is the current in this, or they can ask what is the voltage across the ends of this resistor, or current across this resistor, or voltage across this resistor. Like that several questions can be asked. Any question can form as a MCQ. So they can ask current in this wire, current in this wire, current in this wire, anywhere, whatever they want, just they can write one arrow mark and they ask, call it as I, and they ask what is the value of I. So many questions when you want to answer it. Let me redraw the simplified circuit. So in a video, if I am going on explaining and drawing, it takes more time. So what I do is I finish off this reduction. I know that these two are in parallel. This can be replaced with one single resistance. Formula 1 by R1 plus 1 by R2. Again after that, that becomes series. Again that set and this will be parallel. Again this and this will be series. So those diagrams I finish it off and I redraw a diagram. Then I'll explain the problem. Just wait for a moment. Okay, children, we will continue now. These two combinedly becomes one value that we have to write it. This is unknown for us. This 4 as it is, this 12 as it is, and this 5 as it is, and this 18 as it is, we kept it. So now 6 and 3, when you combine it, we can write it as 1 by R equivalent is equal to 1 by 6 plus 1 by 3. In parallel connection we write like that. Or simply R1 R2 by R1 plus R2 you can write it. Okay, anyhow already started, no? 6 into 3. 3 plus 6. So when you reciprocate 1 by R equivalent, you get R equivalent is equal to 6 into 3 by 6 plus 3. That we are going to use it in the next time. So this is 9. 3 ones are 3 threes are 3 ones are 3 twos are. So this can be replaced with 2 ohms. And this 4 ohms and this 2 ohms are in series. So I am rounding that part which I am going to reduce. So R equivalent is equal to R1 plus R2. That is 4 plus 2. That is 6. So the new value is 6 ohms. The previous 12 as it is I kept it. The previous 5 as it is I kept it. Now these two are in parallel. So this is to be reduced now. This is called successive reduction. So R equivalent is like this. Individual resistance multiplication. 12 into 6 by 12 plus 6. 18. You have to do this only when there are 2 resistances. When you have 3 resistances, you have to do 1 by 6 plus 1 by 3 plus what are, like that you have to do it. 6 ones are 3, 6 threes are 3 ones are 3 fours are. So this is to be replaced with 4. This 5 as it is, this 18 as it is. So this is 4. 5 ohms plus 4 ohms is 9 ohms. So now we don't know potential difference across this resistor individually, but overall once you reduce it, you know potential difference, that is this. So this problem came down like this. Now I equivalent is equal to V equivalent by R equivalent. The R equivalent resistance of this circuit, when you replace all of this, 5, 4, 12, 3, 6, we got the answer to be 9 in this particular configuration, in this particular placement, where two of them are parallel, that is in series, that is in parallel, that is in series. It's a combination problem. So it is 18 volts by 9 ohms. That is 2 ampere current is going to come out from the battery. That is 2 amperes current is going to circulate in this. So it gets energy from 18 volts battery and it discharges that energy at different resistors and comes back, and the electrons come with low energy. Again they gain energy in the battery, they go. So electrons will be everywhere, in the plug socket, in the wire, in the battery, everywhere electron will be there. During the circulation they gain energy near the battery, they lose energy near the gadgets, that are the resistances. So again this is not yet over. Across individual resistor, what is the value we need to do it. So if you want up to here, you can take a snapshot. Further I am going to continue. I need some more diagrams. The students will continue here. Just I told you V by R, that is 18 by 9 is 2 amperes current. So from battery 2 amperes current comes out, and again it delivers its energy and comes back into this as 2 amperes. So V is for voltage, A is for current, ohms is a symbol for resistors. So this 2 and they multiply with I into R, 2 5s are 10. So here there will be a drop of 10 volts. So out of 18 volts, 10 volts energy it gives here per every coulomb. Similarly 2 into 4, 8 volts of energy it gives here. So it started with 18, lost 10, left over 8, that also lost here and came back. Again it will gain that way. So you understood what is the voltage across this, what is the voltage across this. Now even if you want to find the current also, 10 by 5 gives you 2 amperes, 8 by 4 also gives you 2 amperes. That's the total current. And in series current remains same. That's the logic we used it. Here also you have 2 amperes, here also you have 2 amperes. In series current remains same. Now what is the voltage across 5 or potential drop across 5? 10 volts. What's the potential difference across this 4 ohms resistor? These two combination given 4 to you previously before rubbing the board I shown. So here you have 8 volts. So now 10 by 5 already are written. This is 2 amperes. So same 2 amperes comes in and same 2 amperes goes out with less energy. And that 2 amperes has to split here and here. It will not split 1 and 1 because here opposition is 6 ohms. Here opposition is 12 ohms. More opposition, less current. Less opposition, more current. So what is the potential difference? You know it, 8. So this will be 8 by 6 amps. And this will be 8 by 12 amps. So simplified value, what is 8 by 6? You can cancel with 2 table. 4 by 3 amperes comes from here. 8 by 12 how much? 4 table, 2 by 3 amps comes from here. 4 by 3 plus 2 by 3. 3 is LCM, 6 you get in the numerator. 6 by 3, you will get 2 amperes. So this 4 by 3, 2 by 3 reunites as 2 amperes and comes back. So whether we are doing problem or not, at every step you can counter verify. Whatever current came out of the battery, same amount of current should go into it. So you understood what is the voltage across 6 ohms, that is 8 volts. What is the voltage across 12 ohms, that is 8 volts. What is the current through 12 ohms, 2 by 3 amperes or 8 by 12 amperes, both are same. And here what is the current, 8 by 6 amperes or 4 by 3 amperes, both are same after cancelling the simplest values. So what is the current across 5 ohm resistor, 2 amperes. What is the voltage across 5 ohm resistor, 10 volts. 2 5s are 10, 10 by 5 is equal to 2, anyway you can get it. Now again same, 2 amperes should go out and 2 amperes should come in. Voltage across this is 10 volts and here 2 amperes is coming in. This 2 amperes splits into, already we done it here, 4 by 3 amps and 2 by 3 amps. So now what is the potential difference across this? 4 by 3 into 4. 4 4s are 16 by 3. So here there will be a drop of 16 by 3 volts. Same 4 by 3 into 2. 8 by 3 volts. Similarly 2 by 3 into 12. 3 1s are 3 4s are, that will be 8 volts. So there is a drop of 8 volts. So if you happen to see 8 volts will be drop across this, 8 volt will be drop across it. That is energy lost per coulomb. So 8 volts, whether this combination is 8 or not, you see 16 by 3 plus 8 by 3, 24 by 3. 24 by 3 is nothing but 8 volts. So addition of this is giving this. So what we have done is correct. So now here the 4 by 3 amps and the 2 by 3 amps reunite to become 2 amps and comes back into the battery. That cycle will continue. Nothing, you don't think that battery gives charge. Everywhere charge exists. Only battery gives energy to the charge which is flowing. So when it is on the flow only, that happens. Now coming back to this again, here 2 ohm, there is a division here. So here this is under 8 by 3 volts. Remaining all same. Here 10 volts, here 16 by 3 volts, like that. So 8 by 3 volts has to supply a current here and a here. So potential difference across this. So 8 by 3 into 6 by 6, sorry. Voltage by resistance is current. I is equal to V by R. 8 by 3 by 6. 8 by 3 by 6. So what happens here? 6 goes here. 8 by 3 into 6. 2 3s are 2 4s are 4 by 9 amps. So there will be a current of 4 by 9 amperes. Here also 8 by 3 by 3. 8 by 9 amps. 4 by 9 plus 8 by 9. 12 by 9. 12 by 9 is nothing but 4 by 3. So these current coming from here and this rejoins as into this as 4 by 3 amps. And this current from here already we know it. It is 2 by 3 amps. So this 2 by 3 amps joins with 4 by 3 amps becomes 6 by 3 amps. 6 by 3 is nothing but 2 amps. Comes back into the battery as 2 amps. So this 2 amperes which is coming from the battery out goes into this as 2 amps. Here it splits into 4 by 3 and 2 by 3. 4 by 3 amps and 2 by 3 amps. It is appearing to be little difficult for you because involvement of fractions. If you take this 18 volts as 90 volts, you try it, or 90, not 180 volts, you take it. Fractions will get to eliminated. You try this at home, don't leave it. So presently it is, let it be 18 volts only. So fractions has come because we have taken the numbers as we like. In this way we have finally reduced the problem. So just give me a moment to rub it. Again I'll explain so many things. See here students, the same diagram I had drawn it little bigger in size so that I have to accommodate voltmeters and ammeters. They can keep one ammeter here, A1. What is the reading of A1 they may ask. Or they may connect one voltmeter here, V1. What's the voltage across 5 ohms resistor they may ask. Or they can keep an ammeter here, A2. Or they can keep one voltmeter V2 here. They may ask I am not saying that they should ask all, but I am going to solve all. They can put one voltmeter or one ammeter at any one place and they may ask you to find the reading. They give the beginning circuit and they'll ask you that. So again you can have an ammeter here. You can put it here or there. Current in series is same. So A3, V3. This is A4. This is A5. Ammeter is always kept in series. Voltmeter is kept in parallel. So it is V4. This is V5. You can have a ammeter here also, A6. You can have an ammeter here also, A7. Now anywhere they can put a voltmeter and an ammeter and they may ask you to find out potential difference or anything. So let me write the answers. A1, A2, A3, A4, A5, A6, A7. So what is A1 reading? This is the ammeter. So current going from here in the circuit already we solved, that is 2 amperes. That's the answer. So what is A2? Current going across this, that is 4 by 3 amps. A3, current going like this, that is this one, 2 by 3 amps. A4, this one, current coming from here across the 6, 4 by 9 amps. A5, current coming from here, this current across the 3 ohm resistor, that is 8 by 9 amps. And A6 is current here, so which is coming like this, that is 4 by 3 again, 4 by 3 amps. And A7 current here after rejoining everything, so 2 amps again. So they may ask any one of the question as MCQ, but subjective wise we solved everything. Similarly, voltmeter readings, V1, V2, V3, V4, V5. Voltage across this 5 ohm resistors is V1, we already told. What was the current voltmeter reading? We have rubbed it off, but 2 5s are 10 volts. So there will be a drop of 10 joules of energy per coulomb of charge. If 3 coulombs passes through that, 10 3s are 30 joules of energy it will lose. So okay, 10 volts and per coulomb it is 10 volts per coulomb. And here V2 across 4. We rubbed it, we forgot, but even now you can get it. 4 4s are 16 by 3 volts. V3 across this we are rubbed off, but okay. 2 into 12, 24 by 3, that is volts, that is 8 volts. V4 here, voltage across 6, there is already written there, 8 by 3 volts. V5 here across 3, when they are in parallel voltage will be constant, across both of them it is 8 by 3 volts, so it is 8 by 3 volts. So everywhere we got the same answer like that. So many questions, so many answers. Now what was the voltage of this battery? 18 volts. Instead of 18 volts you take it to be 90 volts. So all these answers will change now. What was the total resistance? We have found out after reducing this, it came out to be 9. So 10 amperes will come out of this, and 10 amperes comes back into this. So again every answer changes. So like that, what I am saying is solving one subjective problem is equal to solving hundreds of MCQs. Total problem I solved within 15 minutes. You can see the video timing, maximum it will be 15 minutes. But it is equal to covering so many questions, because I don't know, in the examination they may ask this ammeter reading, or they may ask this voltmeter reading, or they may ask this ammeter reading, or they may ask this ammeter reading, or they may ask this voltmeter reading. They may ask you to find voltage or current at any one place. That I don't know which question is going to come. So better to solve completely, understand how to solve a question of this format. Okay. Yes, students, some children may not like fractions when they are solving this. So I took 162, I just calculated and checked it. 162 volts if you take it, the equivalent resistance I equivalent is equal to V equivalent by R equivalent, that is 162, and we have reduced this finally 6 and 3 combination and all, we got 9 ohms. 9 ones are 9, 18s are. So 18 amperes comes out, and again 18 amperes goes in. Now we have changed the voltage of the battery, we have taken a little heavier battery. Now bigger battery of strength. So 18 comes here. So this ammeter reads as 18 amps. 18 5s, this reads 90 volts. And after that, the current 18 amps has to split something into this, something into this. So out of 162, 90 has been already taken away. So remaining 72 volts. So across this there will be 72 volts. And 72 has to be distributed among 4 and 2. The 6 plus 3 combination was 2. So how will the current 18 amperes get divided? 72, this will be a 4 amperes. So remaining 12 amperes go. So in this 12 amperes will come, here it will be 4 amperes. Just you check it, you do the problem same way, I am doing it little quickly. So I am directly writing ammeter readings and all. This is 12 amperes and 12 4s are 48 volts. So out of 72, 48 is lost here. So 36 volts will be across this. So this will be 36 volts. This also will be 36 volts. Voltage by resistance gives you current. 36 by 3. 3 ones are 3 2 are 12 amps. 36 by 6. So it is somewhere we gone wrong. 1 second. 72 minus 48. So what is 162? 72 minus 48. 4. And this is 24. This is 24 volts. This also will be 24 volts. So 24 by 3, 8 amperes. 24 by 6, 4 amperes. So this 4 amperes and this 8 amperes joins as 12 amperes. So this will read 12 amperes. This was coming out to be 4 amperes. This 4 amperes, this 12 amperes rejoined to get 18 amperes. So if you want to avoid fractions, those numbers, then you take this, solve this problem by taking this as 162 volts or multiples of it. 162 2s are, 162 3s are, like that you can take, or half of it also. 81 volts you take it and do it. You can avoid fractions. This is the way we have to solve the problem. They can ask any ammeter reading or any voltmeter reading, and they may, if they change, for example, this 6 they make it 7, everything gets changed. This 3 they make it 4, everything gets changed. Any one point if they make a change, everything gets changed. That's why learning a subjective problem and trying to do it and analyzing the method becomes more important than solving one particular specific problem. Yes students, there is a little easier method, alternate method is there, but for that you should know Kirchhoff's laws. Even if you don't know Kirchhoff's laws, I'll tell you one point, that at junction current will not be accumulated. So incoming current will be there, outgoing current will be there. There will not be an accumulation of current at a junction. Junction is a point where 3 wires meet. Junction is a point where 3 wires meet. This point, not this one. This is single wire. So if you have this 18 volts, you can split that into 18 volts and 0 volts like this. So this point is under lower energy and this point energy is at higher energy. You can take it as 20 and 2 also you can take. Whatever way you want you can take. But this is the easier one. So I keep this. There is no resistance here. So there will not be drop of any energy there. There will not be drop of voltage. So this is 0, this is 0. When this is 0 here there is no resistance, so this is 0. When this is 0, this point is also 0. So we have kept all the potentials. Now 18 is there, in between resistance is there. When resistance is not there, continue like that. You can make this is also 0, you can write it. Here also you can write 0. Here when there is no resistor you can continue like that. But in between resistance has come and there is a point, and that point energy you don't know. Energy per unit coulomb. So you call it as X. Again after X you have a point there, both the points energies you know, but this is assumed value, still not found out. So here again you went through the resistor, again you have a point there that you call Y. Then if you can assign the potentials like this method is called assigning potentials method. Compared to the long lengthy method what we done, it can be done doing the problem more quickly. So at this junction where there is unknown, you assume that this unknown is there, no? So outward current is equal to 0, because there should be inward current. So X minus 18 by 5 potential difference by resistance is the current, plus outward X minus Y by 4, X minus Y is the potential difference by 4, plus X minus 0 by 12 is equal to all the outward currents you have taken is equal to 0, because there will be some inward currents also. If all are positive values, you cannot get 0 answer. One of them or two of them should be negative. Similarly, there is another unknown junction here, this one. So 4 Y minus X outward current by 4 ohms, potential difference by resistance V by R is I, plus this one Y minus 0 by 6 plus Y minus 0 by this resistance 3 is equal to 0. So you got two equations and two unknowns are there, x and y. Solve them. And as the problem already we have solved it, 2 5s are 10. So from 18 you have to drop 10. So x comes out, this point energy comes out to be 18 minus 10. 8. So on solving these equations, x comes out to be 8 volts. Similarly, here it is 8, no? Y is equal to 8, some drop will be there. 4 by 3 minus 4, 16 by 3. 24 minus, so it is 8 by 3 will come. So x value will finally come out to be 8 volts. Y value will finally come out to be 8 by 3 volts. So for that, the student must take a pain to solve these simultaneous equations. Take LCM, find x and y by solving them. In that way, you'll get x value as 8 and y value as 8 by 3. Once you know this as 8 and this as 8 by 3, you can calculate current at every point. So now I want current in this. 18 minus 8, potential difference, 10 by 5. So here it is 2 amps. This 2 comes as to be what? 18 minus 8 by 5. That is 2 amps. Similarly, 8 minus 8 by 3 by 4. 8 minus 0 by 12. 8 minus 0 by 12. That comes out to be the same current what you got. 2 by 3 amps. Like that you can get current anywhere. This is the method of doing a problem using Kirchhoff's law. So same problem I developed and taught you in different ways. The approach is called Kirchhoff's law approach, where we take a junction where we say that no current will get accumulated here. Incoming current will be there, outgoing current will be there. And while solving the problem, we assume that all currents go out. This we take the highest value. 8 minus 8 by 3, 8 minus 18. So compared to this, when you make 8 minus 18, you get a negative value. 8 minus 8 by 3, you get positive value. So sum of positive and negative values is accounted to be 0. Similarly, compared to 8 by 3, there will be a higher point. Compared to 8 by 3, there will be a lower point. Potential difference, this is positive. Potential difference, this is negative. Then this is accounted to be 0. That casually you do it. Taking one of the point have high potential, you assume it, and all other points are low potential, you assume it. That will never happen. So incoming current should be there, outgoing current should be there. From higher level to potential to lower potential, there will be incoming current. From higher level to lower level, there will be outgoing current like this. So compared to this is low, so it will go out. Compared to this is high, it will come in. This is the way you can even analyze the question. This question I solved it in 2 different ways. Please try to understand them.